So we've looked at implicit and explicit functions. What I'm going to do here is I've got a couple of questions for you. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answers with the working I'm going to present here. So here you go. So I've got two questions for you. First, I just want you to find dy by dx for this set function here. And then the second one, I want you to take it a little bit further and find the equation of the tangent for a set curve at a set point. So pause the video and have a go at those. So the first one, find dy by dx for e to the cos x plus e to the sin y equals 2. So for this sort of question here, again, remember what we do. Take the derivative of every single term going along, then rearrange it until we get dy by dx equals. So we start left, we work right. So e to the cos x, derivative of e to the cos x is minus sin x e to the cos x. I've then got this here, so I've got plus e to the sin y, and I'm then going to multiply it by the derivative, d by dx, of sin y, and that's then going to equal 0. Now, you might look at that and think sin y, derivative of that with respect to x at 0, but remember, y is equal to some function of x. So what we have to do is take that into account when we do this. So what that means is the derivative with respect to x of sin y is actually equal to cos y times the dy by dx. Once we've got that, we now have the function the way we want it so that we can start rearranging it. So I've got minus sin x e to the cos x plus cos y e to the sin y times dy by dx equals 0. So I'm going to shift everything across here without a dy by dx in it and then rearrange it so I'm just left with a dy by dx on this side. So if I shift this across, I've got cos y e to the sin y times dy by dx equals sin x e to the cos y. What I'm then going to do is shift all this across here so that I'm then left with dy by dx equals some function involving x and y. So what that then means is I've got dy by dx equals what was on this side, so the sin x e to the cos x, now divided by cos y e to the sin y. So there you go, that's me found what dy by dx is and expressed it in terms of both x and y when I was given this function at the start. Now the second question wanted me to find the equation of the tangent for this curve at this point 1, 3. So what I have to do is remember to get the equation of the tangent. It's a straight line equation. So I want y equals mx plus c essentially to be the format, or the ax plus by plus c equals 0. One of those two formats dependent on the numbers, but the bottom line is I need the gradient m and I need a point. Well, I've got the point there, I just need the gradient. Now remember, the gradient is equal to the derivative at that point. So first thing I do is work through the derivative of this, substitute in the point and find out what the value is, and then it's just substituting parts into an equation. So take the derivative, I get 2x plus 3 times y plus 3x times the dy by dx. Take away 3y squared times dy by dx equals 2. Now, there's a couple of different ways I can approach it at this point. What I can do is rearrange it so that I get dy by dx equals, and then substitute in the point. Or what I could do is substitute in the point now, and then it's just numerical values I'm mucking about with. So at this point, if I put x is equal to 1, y is equal to 3, what I'll end up getting is 2 plus 9 plus 3x times dy by dx, so plus 3 dy by dx's. Take away 3 times y squared times dy by dx, so y squared is 9, times that by 3 is 27, so then take away 27 dy by dx equals 2. So now it's just a case of playing about with some numerical values. So 2 plus 9 is 11, and what I'm going to do is shift it across to this side. I've then got 3 take away 27, so I know negative 24 dy by dx is equal to 2 take away the 11, which is negative 9. So for that, I know that dy by dx is equal to 9 over 24, and if I divide them through, that's going to give me 3 over 8. So there you go, I've now got the gradient of my line. What I can do is substitute it into the equation of the line along with the point and get the answer I'm after. So let's go for the format y minus b equals m, bracket x minus a is my starting point. I know the a and the b come from here, and the m is the gradient. So I know y minus 3 equals 3 over 8, bracket x minus 1. Now because this is a fraction here, I'm going to multiply both sides by 8 to get rid of it, and eventually I'm actually going to express my equation of the line in that format. So what I end up getting is 8y take away 3h, which is 24, equals, multiply out this bracket by 3, 3x take away 3. Stick it all on the left hand side, and what I end up getting is 8y minus 3x minus 21 equals 0. So that there is the equation of the tangent for that curve at the point 1, 3. So it's not hugely difficult to then start applying it to equations of lines and working with gradients. We just have to remember the basic premise of straight lines. So what information do we need? The key part being the gradient, which is given, as we've just shown here, by the derivative. So bear that in mind when you're working it through, and you'll be fine and dandy with a question like this.